My name is Mike Harris. I'd like to thank you for inviting me to speak today. I'm going to speak about how Deming's work on quality helps us. Before I start, I'd like to say a couple of words about myself. I am the solo tester at Geckoboard, and we aim to give every person in every organisation access to relevant and understandable data so that they can make better decisions. We help them do that by helping them make dashboards, such as the one on my slide, and helping people share those dashboards. I'm also Vice Chair and Programme Secretary of the British Computer Society's Specialist Interest Group in Software Testing. Now, I'm going to speak about W. Edwards Deming. I think probably most of your C-suite know who W. Edwards Deming was. I think there might be some agile coaches in the audience who know who W. Edwards Deming was, but I think everyone involved in development would benefit from knowing about the work of W. Edwards Deming. That's because it will give us a better understanding of quality. It will give us a framework for collaborative working, and it will help us testing, and it will help you if you want to go into management. And I also say it fits very well immediately after Mohammed's talk, because Deming was a big influence on Toyota. So Toyota is one of the things I will cover in my talk. Now, I became interested in Deming when I started to work in agile and lean teams, and I was interested as to what agile and lean were and where they came from. I read a lot of books, I went to talks, and what I found is when I read books about lean and agile, they nearly all mentioned this person called Deming. So I worked out he was very important for lean and agile. And when I came across his work on quality too, I came to feel that testers would benefit from knowing about his work. Now, before I really dive into my talk, I want to give a quick bit of background about lean and agile. Now, when I started to read about lean, I discovered that lean is an American description of Japanese production systems. And this description comes from a study done by MIT. An actual phrase of lean comes from a dissertation done by an MIT researcher who said that Japanese production systems are lean because they do more than mass manufacturing with less. Of primary interest in this study is the Toyota production system. Also coming out of this study is the book, The Machine That Changed the World, which is an analytical history of car manufacturing. And I found very interesting. I found that I could relate to a lot of the stories about engineering teams. And at the same sort of time as this study was going on, Mary Poppendick was working in her factory in America, and they found that the Japanese could produce the same goods as them and sell them for a price that was lower than they could produce them. And the factory was faced in a very difficult situation. And what she did is she got a book by one of the Toyota engineers, and she implemented the principles of the Toyota production system in software development. And through doing that, she saved her factory. But she also created what she called lean software development. And after this, she wrote several books with her husband, Tom, about lean software development. And this is where we get the phrase lean software development from. Now, when I read about agile, I found that agile had quite a different background. If you think of agile being an iterative and incremental development methodology, you could say it started in the 1930s with Bell telephones using the Shewhart cycle, but I'll say more about that later on. Independently of Bell telephones, in the 1950s, IBM had a software development team that worked in an iterative way. One of the engineers was Jerry Weinberg, and he said it felt very natural. He thought that the team manager knew von Neumann, and this is probably how von Neumann saw software development. And at the same time as this, America was developing the X-15 jet plane, rocket plane. And this was developed in an iterative way. If you've seen the film about Neil Armstrong called First Man, this is the rocket plane he's flying at the beginning of the film when he's bouncing around the outside of the Earth's atmosphere trying to get back into the Earth. The X-15 was regarded as a success, and the engineers went on to work for NASA. And they influenced NASA engineers to work iteratively, who in turn influenced NASA software engineers to work iteratively. And on the Mercury project, which ran between 1958 and 1963, they had iterations, they had time boxing, and they wrote their tests before they wrote their code. And what's also interesting is if you think about the whole of the NASA program to put an astronaut on the moon, you can see it as being iterative and incremental. The first rocket, Mercury, put 1 astronaut in space. The second rocket, Gemini, put 2 astronauts in space. The third rocket, Apollo, took it in that iteration, took it an increment forward and put a third astronaut into space. And after that, they went into space with a lunar module, and they went round the moon, and then they landed on the moon. So the whole of the process can be seen as being iterative and incremental. At the same time as this was going on, Lean was being developed, and Lean also contributed to Agile. If we move forward to the 1990s, you'll find Schwaber and Sutherland, who developed Scrum, first presented Scrum at a conference in 1995, and Scrum is now the most widely used Agile methodology. And the Agile Manifesto itself was written in 2001. I found it very interesting that so much of Agile was in place before the Agile Manifesto was written. Now, this is a new slide about DevOps. One of the people I've been talking to recently is John Willis, who's one of the creators of DevOps. And this slide is largely taken from one of his friends called Mike No. And it shows a very similar history to DevOps. One of the things that John Willis says is there's a very simple history of ideas in software development. We have Deming, Toyota, Lean, Agile. And that basically is the history of ideas in a very, very short form. And you can see this again here in DevOps. You can see at the beginning is Toyota with Taiichi Ono. You have Deming giving his lecture in Japan. You get Agile development. Then you have the rise of DevOps. And right at the end, we've got continuous delivery. If you think of DevOps as being the outcome of applying the most trusted principles from physical manufacturing and leadership to the IT value stream, you can see why that's the case. But then why talk about Deming? And I have to say, I've brightened up my slides with pictures of Toyota cars, as Toyota is a primary interest in the study of Lean. We want to talk about Deming because Deming believed quality is central to success. He worked with Japanese industry immediately after World War II, when Japan had a negative net worth, and helped it grow to become a global success. Japan not only had a negative net worth, it also has no coal, no oil, no gas. At that point, it had no timber industry. It had a reputation for shoddy goods. And also it being just after World War II, 70% of Japan's ports were destroyed and 40% of Japan's cities had been destroyed. And Deming helped them turn that round to become a global success. I also looked for a quote which describes how important Deming is as a management scientist. Deming is occasionally mentioned as perhaps the most important management scientist of the 20th century. And in my opinion, this is greatly deserved. That's from David Anderson. Deming's ideas influenced both Lean and Agile, which is important to us, and I'll come on to how that is. And his ideas are still influencing new ideas today. This is a book that I taken from our office library, Competing Against Luck. It is the book about jobs to be done. Jobs to be done is very heavily influenced by Deming. This book mentions Deming all the way through it. I think I should also briefly say who was Deming. Here's a picture of W. Edwards Deming drinking a Japanese cup of tea. He is known for his respect of Japanese culture. Deming worked with Walter Schuhart of Bell Telephone Labs in the 1930s, but is primarily known for his work in Japan after World War II. In 1950, he was invited by the Union of Japanese Science and Engineering to teach statistical methods to Japanese industry. And at one of his lectures in 1950, attendees included the top industrial managers representing an estimated 75% of the industrial capital base at that time. Today, the annual Deming Prize is the leading award for quality in Japan. And the medal you can see on this slide is the medal you receive if you win the Deming Prize. I had a quick look at the Deming Prize. Entering the prize is very demanding. There's lots of detailed questions you have to answer about process, but actually winning the prize is very competitive. Everybody wants to win. Deming's also been called the architect of Japan's post-World War II industrial transformation, and he received an honor from the Japanese emperor. The honor he received is the highest honor that can be given to a foreigner, and the citation stated that the Japanese people attribute the rebirth of Japanese industry to his work. Now, before 1980, Deming was not well known in America. But in 1980, the documentary, If Japan Can, Why Can't We, introduced Deming's methods to US managers. And I had a conversation with Deming's grandson, Kevin Cahill, a little while ago. And what he told me was that at the time this documentary was shown, there were only 3 TV channels in the United States. So millions of people watched this documentary. This was a big breakthrough for Deming, and it led to him working with Ford and Procter & Gamble, and he went on to help Ford become the most profitable car manufacturer in America. He also received a medal from the President of the USA, and in 1993, he founded the Deming Institute. And unfortunately, that year he died. But if we're talking about Deming and quality, what did Deming say quality is? Deming says quality can only be defined in terms of the agent. And I think we can see what he means by that if we talk about a book. The first agent for a book would be the writer. And for a writer, quality is something about the have they managed to tell the story that they want to say? Have they managed to get the points over that they want to get over? Have they managed to use the prose style that they wanted to use? Another agent for a book would be a printer. And for a printer, quality would be something to do with the quality of the ink, the quality of the paper, and the size of the print run. Another agent for a book would be the publisher. For the publisher, quality could quite simply be how many books did they sell? And another agent for the book, of course, is the reader. And for the reader, quality would be, was it an exciting read? Was it a good story? Was there some spark of knowledge? I find this is a very good way to help me understand quality. If I start off by thinking about my team, well, actually, one agent is the back-end developer, and another agent will be a front-end developer, and they have different understandings of quality. They really need to understand what quality is to one another to be able to work together. But actually, customers are really what this is about. The customer, Deming said, is the most important part of the production line, because without him, there is no production line. So actually, if you use this thinking about agents within your customers, there are always many different agents within the customer. There'll be the manager who's running something. Their needs will be one thing, and there'll be the person at the front end. Their needs will be quite different. And if you start thinking about what agents you've got within your customers, it really helps you start thinking about quality. It's also worth pointing out that Deming believed customers didn't always know what they wanted. He said a customer can seldom say today what new product or service would be desirable or useful in 3 years' time. But if that's what quality is, who's responsible for quality? Deming says the responsibility for quality rests with top management, and he says quite simply it cannot be delegated. He gives the example of a company that delegated quality to the factory managers, and they found that different factories produced different levels of quality. So overall, the level of quality fell. One of the reasons for this was that the factory managers had no part in the design of the product. So it was actually unfair to give them responsibility for the quality of the product. I think this is quite a useful metaphor. If we think about us today in software development teams, it's frequently said that the team is responsible for quality. But when you think about it, what do we control as a team? Do we control the team structure? Do we say how many teams there are? Do we actually say which teams get a designer, which teams get time for the product owner? Do we get to choose which teams we as individuals belong to? Do we also get to control HR policies such as annual review systems and training budgets, which have a big effect on motivation and morale? Do we also get to decide what we are working on and when it's released? I think the answer to all those things is no. So I actually think it's unfair to say that the team is responsible for quality. Deming said that quality is determined by the management. Now, why is quality important? Quality is important because quality improves productivity. Deming went beyond that. He says that there's a chain reaction. He says if you improve quality, you will also improve productivity. If you think about within ourselves, if we improve quality, there are less bugs. So there are less bugs to fix. So we can be more productive and we can produce more new features to engage more customers. And if we haven't got to fix bugs, then we've got lower costs. And because we've got lower costs, again, we can produce more new features. And if you've got lower costs and more new features, we can capture the market. So there is a chain reaction of improving quality, improving productivity, lowering costs, and capturing the market. Therefore, quality affects profitability. Now, Deming gave an example about this when he visited a Japanese factory. He found in the factory that they had a number of different production lines. And at the end of each production line, there was an inspector. And the inspector was checking the quality of goods that came off the production line. And if they didn't meet standards, they went to another production line called rework. And at the end of that production line, they'd be inspected again. Now, what Deming asked when he saw this system was what proportion of the factory's staff worked on the rework production line. And the factory manager said 21% of his staff worked on rework. So Deming's next question after that was, well, if 21% of your staff are fixing substandard work, would it actually be fair to say that you've got another 21% of your staff making substandard work? And the factory manager said yes. So there were 21% of his staff on the production line making goods going to the rework production line, and another 21% of his staff working on the rework production line, bringing them up to standard. 42% of the factory staff were either making or fixing substandard work. Deming's solution to this was, in fact, that they should remove the inspectors from the end of the production line. And then you should, instead of trying to inspect quality in at the end of production, you should be trying to build quality in. So what Deming said they should do is they should create operational definitions for what is required at each stage of production, and that way build quality in. Deming said the factory followed his recommendations. They were able to improve quality, improve productivity, lower their costs, and become a success. And I think the story is really very interesting, because if I compare the first production software development team I worked in to the team I worked in today, they're really very different. And it's like the differences within the factory. The first software development team I worked in, the developers were at that end of the room, the testers were at that end of the room, and we were discouraged from talking to one another. As testers, we only worked on tested work that was deemed to be finished. And if we found a bug, the developers had to stop work and fix it so that we could continue testing. That way we were trying to test quality in. Didn't really succeed. Today at Geckoboard, we work quite differently, and we all work together, and we try to build quality in. But then, what are these operational definitions that Deming mentioned? They're really very powerful. Now, what Deming says is an operational definition puts communicable meaning into a concept. Adjectives like good or bad, good or reliable have no meaning until they're expressed in terms of sampling, test, and criterion. I find this a really very useful definition. I suspect all of us at some point in our career have been to a planning meeting when we've been told we're going to produce a feature that's better, faster, or more usable. But actually, what does that mean? We need to be able to express those things in terms of sampling, test, and criteria. We need to say, if it's going to be more usable, then we need to say who, what sample of our customers are going to find this more usable. If it's going to be faster, then we need to be able to test this. We need to be able to say that currently it's this speed and it's going to become that speed. If it's going to be better, then we need some criterion to say by which it's going to be better. I think this is a really very useful thing for us. Deming took it from theoretical physics, and it's something I always have at the back of my mind when I go to planning meetings. Now I'm going to talk about the Deming cycle. Deming cycle is what Deming is best known for. It's an incremental and iterative development methodology. In the 1930s, Walter Schuhart of Bell Telephone Labs started using a Plan, Do, Study, Act cycle. And he did so because he found that engineering teams that use these cycles produce better quality work. And Deming learned the cycle from Walter Schuhart. Deming presented what he called the Schuhart cycle in Japan in 1950. And what Deming said about this is he referred to Schuhart as the master. And when he presented the cycle in 1950, he called it the Schuhart cycle, but it went into use as the Deming cycle. Deming wrote about the cycle under continual improvement of quality. Now, this is what he presented in 1950 in Japan. You see, the cycle has 4 parts. The first part is that the team should decide what are the most important accomplishments for the team. The team should then carry out the change or test decided upon. And in the third part, the team should observe the effects of the change or test. And in the fourth part, the team should study the results and consider what did we learn. Now, this is how Deming described the Schuhart cycle. Schuhart originally had 3 points in a line, but he changed it to be 4 points in a cycle. And the cycle is something the team should repeat, and they should move forward with the knowledge accumulated. Now, Deming simplified the language of the cycle. He changed it to a plan, do, study, act cycle. The first part is the team should plan what the team will do. Second part is the team should build and test what they've planned. Third part is the study. The team should study what went wrong and what went right. And the fourth part is act. The team should change the way of working based on real results. Now, if you look at the diagram here, you can see within the circle there are 4 parts, the 4 parts of the Deming cycle. Because they're all within the cycle, it shows that they're all related to one another. Because they're within a circle, there is no hierarchy. Because it's a circle, it also looks like a wheel, and it's a wheel that rolls forward. There is no beginning and no end, it just keeps rolling, and it's occasionally referred to as the Deming wheel. Deming spoke about it as a wheel which rolls along the line of concepts regarding product quality and a sense of responsibility for product quality. So each time a team goes through the cycle, they will learn more about product quality and their responsibility for product quality. Now, there are a few points I'd like to make about the Deming cycle. The reason to study is to learn how to improve tomorrow's product. Everyone can take part. Everyone has a chance to contribute ideas. Masaki Imai said that Japanese executives recast the Deming cycle into the plan, do, check, act cycle. Deming didn't like this. What he said was that the Deming cycle is a quality control program. It's a plan for management. You repeat the steps, 4 steps over and over. Maybe you could say that Deming cycle is for management and the plan, do, check, act cycle is for a group of people that work on faults encountered at a local level. Deming felt that check wasn't such a profound and deep activity as studies. That's why he didn't like the difference. He felt you need to study. But the difference between the two could also have something to do with translating between Japanese and English. The cycle's also continuing to influence people today. This is another book that I got from our office library. You may well have read it, The Lean Startup by Eric Ries. In here, he talks about a build, measure, learn cycle, and he just got a diagram of it on the front page. You can see here, it's a circle. There are many people who say build, measure, learns, not unlike plan, do, study, act, and that this is an example of influence of the Deming cycle. You also have to say the cycle influenced Toyota. In the book The Toyota Way, Jeffrey Leiker says that the Deming cycle embodies the learning cycle in the Toyota production system. Now, when I first read about the Deming cycle, it sounded rather familiar to me. And that's because I was working in a Scrum team. When I read a book by Jeff Sutherland, one of the 2 co-creators of Scrum, I found that he says in there, the Deming cycle is how Scrum product development is done. And that when he wants to teach people about Scrum, he does so with the plan, do, check, act cycle and trains people to make paper aeroplanes. And he's found that if teams go through the cycle 3 times, they get significantly better at making paper aeroplanes. This is as Deming predicts, because he says as you go through the cycle, you will learn more about quality and get better at what you do. Jeff Sutherland also said that print retrospectives are the check part of the plan, do, check, act cycle, and it's important to move the team onto the act part so that the team makes improvements. Now, I use the plan, do, study, act cycle myself when I do test automation. This is how I use it. And the first part is plan. I plan the test. This includes planning what function and modules I will need and how I will assert that the test has passed. I then go to the second part, do. I then do the test automation. I automate the test using my plan. I then go to study, and I study the test. I run the test. I run the test and I study the results. I run the test several times, both locally on my workstation and on CI, and I study the results to see if the test ever flakes. And if it does flake, if it does fail, I then need to look at the test. I then act on the result of my findings of my study, and I plan a new study act cycle and plan a fix for the failure. I've found this a really useful way to work. Each time I go through the cycle, I learn about the application I'm testing, because I'll be learning out how the pages are constructed. I'll be learning how to interact with different components. And I also learn about the tool that I'm using to automate the tests, because I'll learn how to use that particular tool to automate tests for that product to interact with this element or that page. The full title that Deming gave the cycle is the Shoe-Heart Cycle for Learning and Improvement. And for me, that's what it is. It's about learning and improvement, because I've been learning about the product I test, I've been learning about the tools I test, and I've been improving how I can make tests in that way. And I've been automating tests with two different tools: Ghost Inspector, which is a low-code tool, and Playwright, for which I use TypeScript to automate tests. They're both two very different tools. And this Plan, Do, Study, Act cycle helps me with both tests. I've been able to automate tests much better with that. I'm responsible for hundreds of tests that run every day and are reliable, I think largely due to this cycle. Now, I would say that the Deming cycle empowers us. And I would say that it empowers us because if we use the Plan, Do, Study, Act cycle, we can use it to learn and improve our work. If we work in lean or agile teams, the Deming cycle is already helping you, because it should be part of how you work. It also helps us because the Deming cycle is about continuous improvement of quality. We know that we can use retrospectives to use issues that help us to improve quality, and we should feel empowered to improve quality. Now I'd like to come on and talk about Deming's 14 points for management, because the work we do is done in a context, and that context is created by management. As I said earlier, I once worked in a team where developers were at one end of the room, testers were at the other end of the room, and we weren't supposed to speak to each other. That context was created by management, and it was hard to do good quality work. Now, Deming said that these points were the basis for lessons to top management in Japan, and that adoption of the points is a signal that management intend to stay in business. He also said that the 14 points apply anywhere, both to small and large organizations. Now, the first point is that we need to create constancy of purpose for improving products and services. Deming said that best efforts are not sufficient. Principles are required. You need to know what business you are in. The problems of the future require consistency of purpose. An example he gave was that when he was a child and he went into town, he went on a horse-drawn buggy. And if they wanted to go faster, his father would crack the buggy whip. But the horse-drawn buggy was soon replaced by the car. And buggy whip manufacturers went out of business because they defined their business as manufacturing buggy whips. And Deming said when car manufacturers came in, if they defined themselves as carburetor manufacturers or clutch manufacturers, they too would go out of business. But it's interesting now with the development of electronic vehicles that in fact I'm not hearing about car component manufacturers go out of business. So they must have redefined the way that they do business so that they can cope with this huge change. I also think this is an interesting point to consider now, because we're just after COVID. You know, if we compare the way that we live and work before and after COVID, there are big changes. The same is true for our customers. And I think many businesses will have had to change the way they define their business post-COVID. We need to find ways of defining what business we're in so that we can cope with the next big change. Jeffrey Leiker in the Toyota Way said that this point reminds him of Toyota and explains why they are successful in terms of sales and profits. So I'll just have a glass of water. Point 2 is that we need to adopt the new philosophy. Buying your product is not a privilege. Customers have choice and don't want to buy products or services that have defects. Point 3 is that we need to cease inspection. and cease dependence on inspection to achieve quality. If you think about the story I told about the Japanese factory that moved from inspecting quality in at the end of production line to trying to build quality in, that's something that we need to be doing. Rework, which can be caused by inspecting quality in after the whole product has been created, is expensive. We want to reduce rework. We don't want to be like that development team where testers were only testing quality that had already been finished. We want to be testing work as early as we can so that we can build quality in. And I'd say that's what we're trying to do today at Gecko Board. Point 4 is that we need to end the practice of awarding business on price alone and instead minimize total cost by working with a single supplier. Deming was talking about how manufacturers should build relationships with suppliers and work together to improve quality instead of just cutting the price of suppliers. This feels to me rather like working with software vendors. I had a friend that worked with a large company and they put their website out to tender and they went with the lowest bidder. When my friend went in there to see the contractor who had won the bid, he found that one of the ways that they had won the bid was by instead of using GitHub, they used a shareware alternative. And because that shareware alternative didn't support PRs, they didn't have a system for code reviews. Well, you can imagine the issues they had with quality. That company would have been much better off working with a single supplier and working with them to improve costs and improve quality. Now, what Deming is doing here is he's using systems thinking to say that the company and the supplier are one system that produce a product or service for the customer. And that's a very useful process for us to have, to think about the system that we're working in and what the boundaries of it and how we can work with suppliers as well as with our colleagues. Point 5 is that we need to improve constantly and forever every process for planning, production, and service. This is because when you improve quality, there is this chain reaction. Improved quality improves productivity, which lowers costs and helps you capture the market. Key question to ask is every job being done better than it was before? Point 6 is we need to institute training on the job. We need to learn about the company. We need training and retraining for the job. The greatest waste is the failure to use the abilities of people. An example of this would be an induction process which failed to induct somebody successfully into the company. Hire and fire is easy, but you actually have to think about it's too easy. But actually, you need to think about the cost to the company. The cost of hiring is really expensive. You found somebody and then you've got rid of them. You're going to have to go through that process again. We need to make sure that we have good processes that make the best of our people. A company's most precious possession is the people who work for it. Companies need to invest in people as well as in equipment. Point 7 is that we need to adopt and institute leadership. Deming said that a manager is a coach and a counsel, not a judge. We need leadership, not management. Leading people is helping people to do a better job. Deming called management supervision. This is a really big put down. In a few years ago, the bottom tier of management was called supervisors, supervision. And actually, they were so low down the pecking order, they weren't even called managers, they were called supervisors. So Deming here is really putting down the whole concept of management. What he says is supervision should be replaced by leadership. A leader tries to create for everybody interest and challenge and joy in work. A leader teaches them cooperation, and a leader works by cooperation. Point 8 is you need to drive out fear. No one puts in their best performance unless they feel secure. C comes from Latin without, and cure comes from fear or care. So secure means without fear. Fear prevents people from answering questions honestly if they want to protect their job and the job of their friends. And it also prevents people from asking challenging questions that need to be answered. And for testers, this is really important because we need to be able to ask challenging questions and we need to be able to ask naive questions. So I think this point is particularly relevant to us. Point 9 is we need to break down barriers between staff areas. If we do not understand each other's work, there will be a cost of rework. If you think about it within our team, if a back-end developer and front-end developer don't understand each other's needs, there can be real problems with the software. There can be a cost in terms of reworking, in terms of bugs. But if you also think across the company, if, for instance, the development team, we deliver our new feature on time, on price, but actually it creates lots of work for the customer service team, we perhaps have not done a good job for the customer, for the company and for the customer. What we actually need is teamwork throughout the company, because that way we can take into account each part and be successful as a whole company. Point 10 is that we should eliminate slogans, exhortations, and targets for the workforce. Slogans like "be a quality worker," "take pride in your work," they're directed at the wrong people. They advertise that management is unaware of the barriers to prides of workmanship. I had a friend who worked for a startup in London that was successful. They got a successful exit. And one of the first things the new fund did that when they bought the company is send slogans on pieces of cardboard to the company and instructed them to put a slogan up in each meeting room. You can only imagine how that went down. Point 11 is that we need to eliminate numerical quotas for the workforce and numerical targets for management. This is because they will meet them whether or not they are useful. An example I found was in car manufacturing, and there was a story from a car production line in America that the American-made parts didn't always fit, but the Japanese-made parts always fitted. And what they found is the Americans had set a goal. The parts needed to be 500 millimeters long, and the Americans had set a tolerance between 495 and 505 millimeters, so that their parts always met that goal, but they didn't always fit. The Japanese didn't set a goal. They just aimed to continuously get better, and their parts were very nearly 500 millimeters long. That's why they always fitted. Point 12 is that we need to remove inhibitors to good work and eliminate the annual rating or merit system. People problems are complex. How can you do good work if you don't know what's acceptable? If people are made to feel a commodity, it doesn't help. We've all heard the phrase body shopping. I would also say that challenging society's biases and prejudices fits in here, because an inhibitor to good work could be actually that your team doesn't have any women engineers, or that if your team does have any women engineers, that in fact they don't feel their contributions are being valued. Women engineers make a huge contribution, and if your team is entirely male or women feel that their comments aren't being valued, then that's inhibiting the performance of your team. So I would say that we need to challenge society's biases and prejudices to remove inhibitors to good work. Point 13 is that we need to institute a vigorous program of education and self-improvement for everyone. There are lots of good people, but we also need self-improvement. We need people need more than money in their career. People need education. People want to be helped to live better. We need to keep people's minds developing, and it doesn't matter if it relates to work. We need to be elevating people's minds. No organization can survive with good people. It needs people who are improving. An example that Deming found was when he went to the Ford Motor Company, they had a joint education program with the union, which included English and maths. That's really good, but it excluded basketball. Deming said it should include basketball because if the workers played basketball, they would learn about teamwork, which is something they need for work. And point 14 is we need to put everyone together in the company to work accomplishing this transformation. Deming said that management will struggle over every one of these points, and that the shoe-out cycle will be helpful, because if management feel they're struggling over a point, they can plan an initiative to deal with it, they can do the initiative, they can study the outcome, and they can act on what they've found. Now, these 14 points of management all support one another. Each of the 14 points is implicit in all the others. The way not to depend on mass inspection, point 3, is to continually improve the process, point 5. To do that, you need quality supplies, point 4. And if finding a quality supplier, you need to remember constancy of purpose, point 1. These points are all one philosophy. An example of how we struggle with the 14 points would be drive out fear. Deming gave examples of fear. He said, I'm afraid to lose my job. I'm afraid that I'll not always be able to answer when my boss asks something, or I'm afraid to make a mistake, or that my boss believes in fear. Now, today, we don't talk about driving out fear so much, but we often talk about psychological safety and the need for psychological safety. This is the same thing. These 14 points I have taken from a book published in 1982. Deming first spoke about these points at a conference in Tokyo in 1978. So this isn't a new issue. And what Deming is saying is that it's the responsibility of management to drive out fear. So I would say that Deming's 14 points for management help us, because this is a theory of management for the improvement of quality, productivity, and competitive position. That's something I want. These points provide support to create a successful work environment. Deming said that management will struggle with them, and when we see management fail, we see that struggle. And if we work under a manager who does not live up to these points, and these points help us see the issue, it's not a personal issue with that manager. It's actually an issue about management education. These points should also make us feel confident, because if there's fear in the workplace, then that's a management failure. It is not our fault. These points also provide ideas that support cooperation and development of human potential. This is important because actually these 14 points are the root of DevOps. I say one of the guys I've been talking to recently is John Willis, who's one of the creators of DevOps. And he says these 14 points, because they support cooperation and human potential, systems thinking, and things like that, they are the root of DevOps. So they're still driving innovation in the 21st century. And to conclude, I'd like to say that Deming's work helps us by giving us a better understanding of quality, helping us with learning and improvement through the Plan, Do, Study, Act cycle, helps us with building quality in, helps us by giving a framework for cooperative working and developing human potential, including psychological safety. We get that in the 14 points. Now, this list of references are the books that I used in helping to create this presentation, and I'll share these on my LinkedIn profile after the conference. And I'd like to finish with a final quote from Deming. He says that we're here to learn, make a difference, and have fun. I hope that you've enjoyed the presentation. I'll be very pleased to answer any questions that you have. Thank you.
Thank you so much, Mr. Harris. It is indeed a really interesting topic to talk about. I do have some few questions right here. I'll start with the first one from Omar. He's asking, Deming's approach is often associated with manufacturing and business processes. How can testers translate these principles into the context of software testing and quality assurance?
Okay, well, I gave the example of Plan, Do, Study, Act, and I think that works very well for test automation, because I found that if I planned something, did something, and studied the result, I could learn a lot about the application I'm working on and about the tool. So it helped me grow as a test automator, helped me create a lot more tests. So I think that's one clear way you can do it. I also think in terms of manual testing, Plan, Do, Study, Act works very well as well, because we may sit there and say, actually, I want to go and test this part of the application, and I'm going to work with this testing charter. Well, actually, after a while, you want to study what you've done, and then you're going to act on what you found. And if you're working in that way, it works very well as a Plan, Do, Study, Act cycle. I picked out the 14 points for management because I think this would make us feel confident. Sometimes as testers, we don't work under places that aspire to the 14 points for management. And these 14 points can help give us confidence that if we've got issues, really, it's really how we're going to cope with management rather than management's actually management having a failure. There are other things as well. I think this concept of quality is useful, using the agents and thinking they show that quality is subjective. So I think that's very useful. There are other things that I didn't cover in the talk. If you were to look up the red beads experiment, you would actually see how workers are being held responsible for quality, when in fact they have no influence over the quality. And that can be an issue that we find ourselves in sometimes as well. And the red beads experiment was a part of the 4-day seminars which Deming used to give to senior management in the 1980s. So that I've got a blog post about it that's relevant to testers. If you look on my blog, you'll be able to see that. I could go on, actually. There's a system of profound knowledge that he developed as well. He said that he was successful in Japan because he had profound knowledge, which sounds quite a difficult thing to say. But what he's trying to say is that he had a deeper knowledge of the issues that were there for us, that the companies were facing. And he said he got that deeper knowledge by considering 4 things. And you think about that, we face problems as well, as testers, as test leads, as test managers. And if you think about those 4 things are psychology. So actually psychology is important. We need to think about how we work together. That's important, whichever one of those roles you have. He also said systems thinking is important. So systems thinking covered actually 2 of those 14 points. The relationship with the suppliers, also considers about working with other people across the company. So systems thinking is important for us as testers, wherever we are. He also said variation. Variation is a natural part of life, you know. I'm in London, you know, I know that the weather's going to change. It's going to vary. Some days it'll be sunny in the morning, and some days it'll be sunny in the afternoon, but it'll probably be sunny and rainy every day. Variation is part of life, and variation is part of our testing. Past succeed, past tests fail. If we're doing performance testing, there'll be different numbers that we'll be measuring and looking at. So variation is part of what we understand. And out of that, we need to develop a theory of knowledge, which is actually very important for us as testers, because Deming says all knowledge comes from theory. So here it gives an example of that with the Old English folk story of Chanticleer, the cockerel. The Chanticleer would wake every morning and he would crow. And he noticed that after he crowed, the sun rose. So he developed a theory that the sun rose because he crowed. One day when he woke up, he forgot to crow, but he noticed that the sun still rose. So he had to change his theory. Because he'd had a theory, he had a theory to change. And because he changed his theory, his knowledge grew. Now, for us, this is very much the same. If we develop a testing charter, and maybe we will bring in some of those things about systems thinking, variation, and psychology into that, that's our theory. And we will develop that, we will test that theory when we carry out our tests. And we may need to revise that theory because of the results of our testing. And because we've had a theory, our knowledge has grown. So actually, I'd say that there's a great deal for us to learn from Deming. His ideas came out of manufacturing telephones with Bell. They went into developing cars with Toyota. But as I said, they're now actually inspiring DevOps, continuous deployment and continuous delivery if you're doing that. So actually there's a huge amount there for us to learn, which is why I do these talks. I think it's very valuable for us. I hope that answers the question, and I hope I didn't talk too long.